Okay, so let's now do some more examples on quadratic equations with the solving technique by solving by factoring. Okay, so we have gone through a few examples in class. However, in these video lessons here, you're going to find more detailed examples here. So example 1, okay, another example besides what you've learned in class. So let's say we want to solve the quadratic equation x squared minus 13x plus 40 equals 0. Now, before we get started, once again, I have to warn you ahead of time, you must get all these factoring skills going. You must have all these factoring skills in all kinds of quadratic equations ready for you to be able to work in these problems here. So once again, if you're feeling shaky with your factoring skills, make sure you refer to those video lessons of mine that I introduce how to do factoring. Okay, so now in this particular example, now one of the general guidelines we discussed in class is that we always want to bring, before you attempt with any equation, you always want to bring all terms to one side and leaving a 0 on the other side. So now what I have here is that in this current equation I'm having all the terms are isolated or are brought to the left side and leaving a 0 on the right hand side, so we are good to go. Now, the second step now is just go ahead and factor the left-hand side, the side that contains all the terms. So now, what I can see here is as a factoring, as you can apply the factoring methods, x squared minus 13x plus 40, it can be, well, at this point you can have quite a few good varieties of factoring technique, but I would say the most common method here would be the guess and check methods, and we have we create for ourselves two pairs of parentheses, and here I have an x, and I have an x, and here what I can see is I'm going to see that there are the two numbers minus 8 and minus 5. The point here is that we're including signs with these numbers. So I want to find two numbers, factor of 40, including signs that are going to be negative 8 and negative 5, so that when you sum these together, they're going to be negative 13. So the two proper number will be minus 8 and minus 5. So I have turned my quadratic into a factor form. I have x minus 8 times x minus 5. Okay? And so at this point, what I'm going to do to the two factors here as a general guideline for the factoring method, you're going to take each factor. So the first factor, x minus 8, you take that factor, set it equal to 0. I'm doing it the same to the second factor, x minus 5, I'm setting it equal to 0. At this point, I have produced for myself two separate equations, and here I'm solving that independently, each equation. So the first equation, x minus 8 equals 0, adding 8 to both sides, that gives me x equals 8. The second equation, x minus 5 equals 0, I'm adding 5 to both sides, and I'm going to end up with x equals 5. And so these are my two obtained solutions to the starting equation, x squared minus 13x plus 40. Example 2, you can see, let's look at example 2, where you can see once again some more of these problems. We're solving quadratic again using factoring method. Now, keep in mind once again, before you can attempt to factor the quadratic equation, make sure you have to bring all terms to one side. So in this case here, this is what I was talking about right here. Now at the starting point of the equations, the terms are not all in one side yet. You can see that we have an x squared term on the left hand side, I have a plus 15x on the left hand side. However, there's like a lonely negative 56x on the right hand side. So what I need to do is I need to bring all terms to one side. And really, I decide to bring my negative 56 to the left-hand side. However, you have your own choice to bring all the terms to one particular side on your own. But then we need to leave a 0 on the opposite side. So what I can see here is that I can do adding a 56 to both sides. Okay, and that's going to bring my equation to x squared plus 15x plus 56. Equals 0. So now at this point I am ready to proceed into my factoring problems. So now back to the factoring problem. Once again I need two pairs of parentheses. Putting an x here, putting an x here. I'm going to look for the two factors of 56, including sign, so that they will sum to be 15. So now the two numbers would be positive 8 and positive 7. And at this point, maybe it's worth to mention once again, it doesn't matter where the positive 8 and the positive 7 goes for whichever pair of parentheses that is. You can also put the positive 7 here and positive 8 on the other side. The point now is that, once again, I have turned my quadratic equation into two factors, x plus 8 quantity times x plus 7. And what I can see now at this point, x plus 8 is the first factor. I'm taking that and setting it equal to 0. I'm taking the second factor, x plus 7, setting it equal to 0. Okay? And so now what I can do here, solving the two equations here independently. For the first equation, I'm subtracting 8 from both sides. That leaves me x equals negative 8. The second equation, subtracting 7 from both sides. That leaves me x equals negative 7. At this point, these are my two final answers to my quadratic equation. X squared plus 15x equals negative 56. The third example I would like to show you, okay, we would like to once again solve for a quadratic equation. I have x squared plus 12 equals 7x. And once again, the whole reason being that I've been recognizing these equations throughout the three examples as quadratic is just because we have the x squared term. The x squared term makes the equations quadratic. So now, what I'm seeing here, once again, I do need to bring all my terms to one side. I do need to isolate the terms here. And what I'm seeing here is I have a single 7x on the right-hand side. I have one lonely 7x on the right-hand side. So what I can do is minus 7x to both sides, and that leaves me x squared minus 7x plus 12 equals 0. So once again, at this point, I'm not done. I'm not getting into any solving yet. I have just bringing the terms around to make my equation in ordinary form. I have brought all the terms to the left-hand side and leaving a 0 on the right-hand side. And here at this point, once again, we need to get back to the factoring problems. I'm producing for myself two pairs of parentheses equals 0 on the right-hand side. So I put an x here, put an x here, and what I can do, I can see that plus 12, I'm looking for the two factors of plus 12, the two factors including signs. I can see that it's best to be minus 4 and minus 3 because negative 4 and negative 3, when you multiply them together, you got positive 12, and when you sum them together, you got negative 7. And so here I have turned my quadratic equation into the factor form, x minus 4 quantity times x minus 3. So what I can do, once again, taking each factor and set it equal to 0. X minus 4 equals 0, x minus 3 equals 0. So in the next step, once again, I'm just adding 4 to both sides of my first equation, and I have x equals 4 as my solution. With my second one, I'm adding 3 to both sides of the equations, and I'm ending up with x equals 3. Okay, so these are my found solutions to the quadratic equation x squared plus 12 equals 7x. The fourth example, let's try another one, another quadratic equation. Okay. Now, if you rewind and look back at any of those examples we've had in the first three examples, you've seen that the equation we've been solving, the coefficient with the x squared, the coefficient in front of the x squared has always been a coefficient 1. Let's say, what about we have an equation, 3x squared plus 5x minus 2 equals 0. Now, don't feel, surprised about this. The only thing different now is that we're having a leading coefficient to be a 3 other than 1. And so once again, I've had some video lessons of how to factor a quadratic expressions with a leading coefficient other than 1. So, and once again, I suppose that you already got all that skills going. So now, this equation here, you do not have to worry about moving the terms to one side because it's already, ready for you. All the terms on one side, the left-hand side specifically, and then leaving a 0 on the right-hand side. Now what you can do is just go straight into the factoring problem. Once again, I encourage you to look back at your factoring skill. But in this problem, as we factor, I can see that producing for yourself 2 pairs of parentheses, I need a 3x, I need an x in the other pair of parentheses. And now the two numbers that's gonna help me find the proper factors here is gonna be -1 and +2. Once again, how I obtain -1 and +2, you must go back and review my video lessons for how to factor these quadratic expressions with leading coefficient other than 1. Okay, so now at this point, we have turned our quadratic equation here into the factor for 3x minus 1 quantity times x plus 2. We have a product of two factors equals 0. And so according to the way we've been doing it, we're taking each factor, 3x minus 1, and setting it equal to 0. So I have 3x minus 1 equals 0, x plus 2 equals 0. And now looking back into each of these little equations, I'm solving for that one by one. And for the first equation, adding 1 to both sides, I end up with x equals 3x equals 1. And I'm not quite done with this one. I need to divide it by 3 on both sides. That leaves me x equals 1/3. So there goes my first solution. Now for the other equations, I'm subtracting 2 from both sides. That leaves me x equals -2. Okay? And so that's how we just handle a problem, solving a quadratic equation using factoring methods with an equation having leading coefficient other than 1.